Students, last point once again observe here. A plus minus A is equal to 0. Minus A plus A is equal to 0. Where minus A is obtained by changing the sign of every element of A, which is additive inverse of the matrix A. Minus A is called additive inverse of the matrix A. Or we can write additive inverse of A. Additive inverse of the matrix A. Additive inverse of the matrix A is what? Minus A. Minus A. For suppose A matrix 1, 2, 3, 4. Then additive inverse of the matrix what? Minus 1, minus 2, minus 3, minus 4. A is the matrix, then additive inverse of the matrix A is minus A. That means change the sign of each and every element. Change the sign of each and every element. Okay. Right. Next, difference of the matrices. That meaning is subtract of two matrices. It is denoted by A minus B. The two matrices having same order, then subtract the corresponding elements. Okay, students. Next, multiplication of a matrix by a scalar. Suppose A is the matrix minus 1, 2, 3, 5. Then scalar multiplication of matrix. That means 5A. 5A. So I multiplied with a scalar 5 to the matrix A. Okay. So that means each and every element multiply with 5. This is scalar multiplication of a matrix. Let's see the definition for that. A is equal to Aij m by n matrix and K be a number, then the matrix is obtained by multiplying every element of a matrix by K is called scalar multiplication of A by K. It is denoted by Ka. Instead of K, I am taken 5. So A is the one matrix. So I am going to multiply with 5. Then the elements is going to change or not? Each element is multiply with 5. Okay, that is a multiplication of a matrix by a scalar. Properties of scalar multiplication. A comma B are two matrices and same order, and lambda comma mu are any two scalars. Lambda into A plus B, that is equal lambda A plus lambda B. Lambda plus mu into A, that is equal lambda A into mu A. Lambda into mu A, that is equal to lambda mu A, that is equal to mu into lambda A. Minus lambda into A, minus of lambda A, lambda into minus A. These are all equal. These are all equal. These properties already you know very well. Okay. Next, multiplication of matrices. When the two matrices exist for multiplication, see here definition. Two matrices A and B are conformable for the product or multiplication. Two matrices A and B are exist for the multiplication. When the two matrices exist for multiplication means number of columns in A matrix is equal to number of rows in B. Number of columns in A matrix is equal to number of rows in B. For suppose, see the example. A matrix having matrix order 2 by 3. B matrix having the order 3 by 2. Here observe that the number of columns in first matrix is equal to the number of rows in second matrix. These two are equal numbers means then we will say that the two matrices exist for multiplication. But after multiplication, what is order of the matrix? 2 by 2. 2 by 2. So A is a matrix, B is another matrix. Matrix multiplication is exist. Then BA will be either exist or need not to be exist. See that BA exist for matrix multiplication or not. B matrix order 3 by 2. A matrix order 2 by 3. So here observe that the number of columns in first matrix is equal to number of rows in second matrix. These two are equal or not? Then after multiplication, what we are getting BA matrix order 3 by 3. Here matrix multiplication AB is exist, BA need not to be exist. If in case BA also matrix multiplication exists, then AB matrix and BA matrix both are not equal. So finally what I am saying means AB is not equal to BA. AB is not equal to BA. Now, when the two matrices exist for multiplication, number of columns in first matrix is equal to number of rows in second matrix. Then only the two matrices are exist for multiplication. See here, properties of matrix multiplication. So here, AB is not equal to BA. That means matrix multiplication is not commutative. Matrix multiplication is not commutative, but it is associative, identity, distributive law also. So AB into C is equal to A into BC is equal to ABC. Matrix multiplication is associative. IA, AI, that is equal to A only. So I is identity matrix. So here matrix multiplication is exist. Next, A into B plus C is equal to AB plus AC. This is distributive law. A plus B into C is equal to AC plus BC. Next, A plus B into C, AC plus BC, distributive law. Next, some more important points in objective particularly. See here, if AB is equal to C, product of two matrices AB, if you got null matrix, then either A or B need not to be equal to 0. Generally, we know that product of two numbers, when it is possible 0, any one of the number is 0 means their product is 0. But here not like that. Not like that. AB, product of two matrices 0 means either A or B need not to be equal to 0. For suppose, see the one example. See the one example I will write here. 1, 1, 0, 0. Then B matrix. B matrix. See how to write 0, 1, 0, 1. I think. 1 C. Right. It is going to. This is 0. This is 1, 1. 1 C students. Here we are getting 1, 1, 0, 0. Okay. Now I'm not able to give the example. Okay, I will give the later, no problem. If AB is equal to 0, either A or B need not to be equal to 0. Need not to be equal to 0. For suppose see 1, 0, 0, 0. This is A matrix. B 0, 0, 0, 1. Observe this. What is the product of these two? Product we didn't discuss. Okay. This product is not equal to 0. Yeah, no. Its product is 0. Null matrix will get. That means 0, 0, 0, 0. Observe here. A and B are not a null matrices. Okay. So finally, AB is equal to 0 means either A or B need not to be equal to 0. Next, another important point. AB is equal to AC. Then B need not to be equal to C, even if A not equal to 0. Generally in algebra, A is cancelled, we are writing B is equal to C. But in matrices, not like that. AB is equal to AC means then B need not to be equal to C. Sometimes equal, sometimes not equal. Next, these 2 points are very, very important, 4th, 6th and 7th. Next, A plus B whole square. Generally, A plus B whole square means we are writing like this. A square plus B square plus 2AB. But in matrices, not like that. A square plus B square plus AB plus BA, because AB is not equal to BA now. If AB is equal to BA means then we can write 2AB. Both are not equal now. So remember it, particularly in matrices. A plus B whole square formula. A square plus B square plus AB plus BA. Same as A minus B whole square. A square plus B square minus AB minus BA. Don't write minus 2AB. Here, A power M, A power M. That is equal to A power M plus N. When it is possible, A and B are two square matrices having same order means it is possible. A power M whole power N. That is A power Mn or A power N whole power. This already we know that in exponential formulas how to write. I power M, I only. That means I is equal to I square value also I cube also I power 100 also and so on. I power n also I only, where n belongs to integer, natural numbers. I square, I cube, I power 100, I power n. These are all equal. Okay, students? So this much concept I am discussed now. Remaining concept we will discuss later. In this concept, we are going to discuss some problems.